Hi, I'm Jack Buffington for Hackaday.com. Today we continue on with part 2 of the Eagle CAD series that we started last week. In today's video we will be showing the layout portion of Eagle CAD. Here we have the schematic that we started last week. In the break I added a bunch of other things to complete it out because it's pretty boring watching somebody just make a schematic. But I'll go over the basic points here. I have an input terminal for the power leads. I have my voltage regulator. I have 2 header pins to allow us to have a ground test point, which is pretty handy when you want to probe around with your oscilloscope. I have a decoupling capacitor, in-circuit serial programming with a resistor pulling memory clear high. You need that in order for the processor to run. We've got our crystal and its 2 associated capacitors, our LED, and a button. And then every I/O pin has a header pin coming off of it so that you can connect to whatever you want to on the prototype board. So that's our schematic as it sits now. In order to get to creating a layout, what you need to do is click on this button up here by the toolbar. And this gives us a window that says, do you want to create this board from the schematic? And what that's saying is, do you want to take all of these parts that you've put on your schematic and put them into a layout file? And I'm going to say yes. So here we have a big rat's nest of parts. Here is our board dimensions as it sits now, and I believe that this is the largest board that we can make in this version. So let's start by moving our processor. And the command for that is MOV, or you can click on this button here. MOVE, I tend to shorten it just because Eagle CAD allows you to do that. And then I hit enter. And now I can click and move this. If I want to move a group of parts, I can type group and draw a box around the parts I want to move. And then I still am in move. It reverted back to that. I can right click and select move group. And now all of those parts have moved. And that's a pretty handy thing to do from time to time. Let's put down all of our other parts. Right now it's quite a lot of moving and just arranging. You kind of want to pay attention to these little lines here. These are showing you where the connections are. And all of these little guys here are my little connection points, the header pins I call them. So I'm going to do that. And maybe you guys can watch and fast forward. So let's say you have a situation where you have 2 parts that are pretty close together and you click and you get the wrong part. In this case, let's say I wanted the right header pin, but it highlighted the left one. Now I could take that left one and move it out of the way and then get the right to do what I wanted with it. But if I click there and I get the left one, what I can do is right click, and that toggles around through all the other likely suspects that you may have wanted to click on. So that's a handy little tip for you. Sometimes you might find that things don't appear to be connected the way that they should. In this case, let's take a group of parts here, and I'm going to bring them over into the layout. And I'm not sure how much we'll see here, but right here is the rat's nest button. And what this does is it redraws all these connections to take the most efficient route. So I just clicked on that, and now you can see that some of them rearranged. And that's a handy little thing. So now maybe, for example, these header pins must be shared with something else because they weren't connecting over to here previously. In order to rotate a part, once you have it in move, you can hit the right mouse button, which allows you to rotate by a certain angle. You can also use this tool, which if I go up here, I can set what I want as far as the angle. So now I can set 45, and now that allowed me to put that part at a 45-degree angle. But I don't want that, so I'm just going to do 90-degree turns in the regular move tool. For every part that you create, you're going to have a center or a 0 point. In this case, this is my input, power input header. And what I have is two holes here that the wire can thread through to provide a little bit of strain relief so it doesn't break right here. Anyway, this is my center part, or center location. This is where I need to grab it by. If I grab over here, it'll probably still get it because there's no closer part. No, it actually missed. So you want to make sure that when you build a part in the library that you put that center point in a convenient location. Don't put it way up in the upper corner of a part or something like that. Try to have it in the center. When grouping, you want to make sure that you surround the center points of all of the parts. Right here I've got the 4 header pins, and even though I'm overlapping one of the pins for the resistor that's right here, I won't get it because I'm not surrounding its center point. If I wanted to actually grab that as well, I would need to, oops, let me do another group. I would need to get its center point like this, and now you can see that it is in the group. Alright, at this point I have all of the parts reasonably evenly spaced so that they are positioned in the most efficient location, so a trace doesn't have to go all around the board to get to a part. At this point I'm ready to start routing all of the wires, and to do that, we can either go up here and type route, or we can use this button right here, which is the route button. And let's just do that for this part. One thing to keep in mind when routing is that the pins of a microcontroller or any various part may not necessarily be on the same spacing as the current grid. Right now, if I go into my grid, you can see I'm spaced on 0.05 inch spacing, and this part right here I believe is 0.08 millimeter spacing. So if you're going to route to a pin like this, it's best to click on the end of the where you want to route that isn't on the spacing that you're currently on. I suppose that's not that clear, but let me give you an example. If I go here and I go to route that, it lines up just perfectly with this pad. And I'll just finish taking that, and the computer will beep when you have completed a route. Now let's try to do this route, and I'll show you what happens if I start here. So far so good, but as you can see, I haven't lined up quite right with the pad. And depending on how different the spacing of the part is from the grid, you may have trouble. So like maybe this right here, this spacing would violate the minimum spacing that my board manufacturer would require. Most likely it wouldn't, but we'll just undo what we did and we'll route from here. So we'll just go along and do these. With your crystal, it's important to keep it relatively close to the processor so that it causes radio interference, and I don't know, this is people always say keep it close, so I keep it close. Also, your decoupling capacitor should be relatively close to the processor. Purists would say I need another one down here real close to the processor, but I have never found that to be an issue with PICs. They seem to be awfully tolerant processors, so I'm not going to do it. I'm just going to have it up by my voltage regulator. If the end point of a route is not exactly on a grid point, Eagle CAD will go ahead and do that, just that last little bit for you, so you don't have an unconnected wire still. Just like within the schematic, if I find that I don't like the spacing of the grid, here it's a little awkward, I'd like to sneak my trace in and over here, I can go into View, Grid, and I'm just going to leave my primary dimension at 0.05, but maybe I might want to change my secondary dimension to 0.0125 inches. I click OK. So now you can see how things are snapping around in here. If I hold down the Alt key, I have many more places that it can snap, and so I can get the trace to go along the route that I want and still have it be nicely evenly spaced. Okay, well, I've got myself into a position where I just don't really have enough room for these traces here. So I'm going to use the group command, and you can group traces as well. So here, unfortunately, right up here, I'm grabbing that corner of that pad, which I don't want. So what I'm going to do is, instead I'm going to use the group command again, and instead of clicking and dragging, I can click, 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 click like this, and surround the area that I actually want to get. And then to complete it, I right click. So now this is everything that's a little brighter is my group, and now I can move my group. Bring that out to give myself a little bit more space. Now I can continue on routing. Okay, at this point I'm about to route some power. I would like to make these a little bit thicker of a trace. So if I go up here, I have the option to change my trace thickness. I think I'll pretty much make them double. So now they're much thicker. A thin power trace can cause excessive noise in your circuit. Not always, but when you're doing higher speed things that are really slogging around a lot of power, you may want to make sure that your power traces are nice and thick. And if you're really getting into stuff where, say, you're using an analog to digital converter with lots of bits, you may want an entire ground plane on another layer of the circuit board. But that's beyond the scope of this tutorial. Here's something that you may want to see. When you're routing your power, you may want to see exactly where all of it goes. So the command for that is show. And I think, where is it over here? I don't even know where it is over here. Oh, here, it's this one, the little eyeball. So let's say I click on my ground. Now it shows me where all of the pins I need to connect to are. So here, this one, it's a lighter color. That needs to get connected to. And this one here, and these two over on the processor. Now that's a very handy feature to have. So let's connect up to some of those now. Route again. Here's a situation where I have to route between two pins on the same processor that are not at the same spacing as the main grid. To keep things lining up nicely, what I'll do is I'll start a trace on one pin. Oh, well, of course this one lined up just perfectly. But if I was going the opposite direction, I don't have an option, and even if I'm holding down my Alt key, I can't quite get there. So if I'm trying to stay with grid units, what I could do is route like this and then stop the trace and then start another trace and route to there. That's one way to do it. Another way is to go into Tools, View, Grid, and instead of having a smaller fraction of what this is, I could just click Finest, and what this allows me to do is pretty much freely move my endpoints to wherever I want, or freely move anything to where I want. let's say you have a trace that needs to go through a more complicated path, where it might need to be on the bottom for part of the way and then it can't go any farther on the bottom. You need to switch it over to the top again. What we can do is you start the trace, make sure you're in the layer that you want to be in. You bring that down to wherever it's going, and then I can hit the right button on my mouse, or sorry, the middle mouse button. And what this does is it switches the layer. Now, if this is a more full-featured version of this program, we would have the option of selecting any of the 16 layers, but we only have 2 layers on this particular version. When I click once again, you can see that a via showed up here. The way that you can control how this via looks is up here. Here's the shape of your via. We have square, circle, and octagon. This is the size of the hole in the center of the via, and this determines the diameter of the annular ring around it, so the diameter of the copper around that hole. If we wanted to be ridiculous, we could do something like this. I'll just undo this trace that I did before, and we'll set this one to a circle. Turn that to the bottom and then turn that to the top. Click there. So now you see we have a huge annular ring on there. We'll undo that. Auto seems to work well, so I just leave it on that. You may choose to keep your vias as squares, which helps if you're doing a circuit board where you don't actually have this solder mask and silk screen. It kind of helps differentiate where the parts go, if part holes are round and via holes are rectangular. So I'll just quickly route this part. One additional thing, when you right click, what that does is it toggles between these different modes. So for example, right now it's on go straight first, then do a diagonal. But if I toggle, now I'm in the mode where it goes directly to there. And here's the mode, it goes diagonal first, then straight. And you can even do ones with curves or even crazy curves. So, oh, that's not the one. Here's the one. So that can be handy sometimes. But anyway, I like working in this mode here. So now we have our board totally laid out, and I'm just going to add in a section where you can prototype things. So I'm just going to change this to 0.1 inch spacing. And I'm going to add a bunch of holes. I can add these not connected to anything. I'm going to make them round, just so that pretty much every part fits through it. I'm going to make them 0.039 inch diameter. And I'll make a column of them. And then what I'm going to do is I'm going to group, and I'm going to cut. It's strange. In this program we have, actually I could copy as well. I can right click and I can say copy group and do that. But sometimes you also want to cut and paste. Say you're cutting something from one layout to another. So I could do cut group, which actually doesn't cut it. It's weird. And then if I paste, I get another one. But this allows me to copy something from one schematic or one layout to another. But I'll just copy. So there we go, and then the final thing that we need to do is move the edges of the board. Now if I grab over here, I move the corner, which I don't want to do. If I grab it more towards the center, I can move the whole line segment, which is handy. Now, this is pretty good, but not great. What we really would want to do is have a little extra room on the board so we can have some mounting holes. So I'm going to grab everything, move it, then I'm going to add some holes with a drill diameter, oops, of 1/8 of an inch. We'll stick them a little bit far away from things. Now we can mount this board with some screws onto, say, a piece of wood or whatever you would need to mount it onto. And we might as well fill up some more space with prototyping. Oh, one thing that you may want to do is you may want to label the version of your board. So we'll call this PIC 18F44J11 board revision 1. And I'm on the bottom layer, so I'm just going to right click and get to my top layer. One quirk about Eagle CAD that is not obvious until you've ordered the circuit board is that this text is what you see here is not what you're going to get after you order the circuit board. If you want to do text that is correct, or what you see is what you're going to get, is you need to do, instead of being proportional, let me enter the text again. Instead of being proportional, I need it to be fixed. Now, when you order that circuit board, it'll be exactly what you see is what you get. To delete that one out, I just hit delete. Oops, I have to enter, then I can delete it. One further thing, let's say I totally screwed up and this trace is all wrong. I want to get rid of it. Well, how do I do that? What you do is you enter the rip command to rip up that trace. Now I can click on the different line segments that I might want to rip them up and they become unrouted again. If I click again on an unrouted, it unroutes the whole trace. So I just did that and the rest of that trace disappeared. So that trace is actually good, so I'm just undoing. So that does it for our layout of this prototyping board for the PIC 18F44J11 for Hackaday.com. This is Jack Buffington signing out.